11 years old. I'm the founder of TasteForTheKids.com, and if you like this video, don't forget to smash the like button and share this video with as many people as you can. And if you're not subscribed to my channel yet, kindly do it so that you don't miss any of my videos. So without any delay, let's get started. And today we are gonna learn about threads in Java. Right, so we are gonna learn about threads in Java, and this is also a very interesting topic. So without any delay, let's get started. Jam! So first of all, we'll see what threads basically are. So threads allow a program to operate more efficiently by doing multiple things at the same time. So while your program is running, a thread can also run, that is, and a thread will basically do a task in the background and give you the result whenever the task is over. So that's how you're, like, if you're doing some intensive task, your application will just not like stop for the user for a couple of seconds, right? So if you do that using threads, it will do that intensive task and give you the result without stopping your application execution, right? So threads are very important for applications, big scale projects and all, right? And like, so they like yeah. So threads can be used to perform complicated tasks in the background. So you can perform complicated intensive tasks in the background without interrupting the main program. For example, a very complex calculation. So if you're doing a very complex calculation, you can do that through a thread, and you can do that in the background and basically continue your execution of your application uh, uh, without stopping because of that complex calculation. And whenever you get the result of that complex calculation, just basically do whatever you want to do with that, right? So it will not stop your program for a couple of seconds also, right? So first of all, we'll see how to create a thread. So there are two ways to create a thread, right? So there are two ways. One is using the runnable interface, and the second is using the thread class, right? So we can use both the ways to create basically a thread. Okay, so first we'll see how to create a thread using the thread class. So there is a thread class that from which you can extend. So you basically you have a public class main, and you can just directly extend it from the thread class, right? So that's how you'll get all the properties and methods inherited in your main class. Then what happens, there is a run method whose body you need to give, right? And this is where all the code of the thread will run. So in your run method, you will basically have the code that you want to run when your thread is executing some intensive task. Over here we'll just do very light tasks, but threads are mostly used for intensive tasks. So over here we have a main method where we are creating an object thread of a main class, right? And then what we are doing thread.start. So there was a start method in our thread class that is extended in our main class, right? So there was a start method in our thread class that is extended in our main class, and then we are doing thread dot start. So it will start the thread, and while executing the thread, it will call the run method, right? And when the thread is executing, it will continue on with the program, and it will print out this code is outside of the thread. And when the thread is executing, it will execute this code is running in a thread. So this execution will not interrupt this execution, and basically this thread will run in the background, and while executing the thread, it will show basically do the task that we have given in the run method, and that is printing out this code is running in a thread, right? So first it will print out this code is outside of the thread, and then it will print out this code is running in a thread because this is lighter. Okay, so this is kind of lighter. It is quicker over here. Instead of like when you will start a thread, it will do all the thread processes and all in the background, and that also takes a little bit some milliseconds time, right? And that milliseconds time only will help this to be executed first before this thread's execution, right? But we'll just see a real type of use case uh, uh, in our further examples. So over here we can see this code is running outside of the thread, and then we can see this code is running in a thread. So it is printing out this code is running outside of the thread, and this code that is there in the run method is not interrupting it. And once it has calculated and done all the things of the run method, it will just execute it. And that is basically it. When it is running the thread, it is just executing the run method, right? So while executing the run method, we found that we are printing out this. So after this, because this is lighter, that's why this will be printed out first, then this is being printed out second by the thread, right? Because we did thread.start, that's why in the backgrounds it is taking the run method and basically running its code while executing the thread, right? I've elaborated too much, I think. Okay, it's okay. Now we are doing the same thing with the runnable interface. So as we know, to extend using the runnable interface, we use the implements method, right? Sorry, implements keyword. So to basically, this is a kind of extends if you want to bring in all the attributes and methods of an interface, right? And then in over here also we have a run method, but we'll first see the main method. In that we are creating an object of a main class, then we are creating an object of the thread class, right? We have not extended from the thread class, but we are creating an object of the thread class where we are passing it a our main object. So basically this thread class object, what will happen in this thread class object, we are passing it an object. So this main object will basically contain the run method, right? And we are passing the thread class this object because it wants to access the main method. If we don't pass it, it will have no access to our main method, and that's why it will not run. But we are passing it the main object. So in the main object, it has a method named run that is being passed with the object, right? Because it is in the object, right? So it is in the object, that's why thread now has that object, and it can access that object's run method, that is this. Okay, and in the run method we always give our code that needs to be executed while executing the thread, right? And then what we are doing after creating this thread object, we are this is again the start method that we are calling, right? And basically this will start the thread, and while executing the thread, it will execute all the thread code, right, that we have given. So we give whatever needs to be executed in the thread, we give it in a run method. So over here basically we are giving system.out.println, this code is running in a thread, so that will be executed while executing the thread, right? So and then over here, while this is happening in the background, we are printing out this code is outside of the thread. So we'll get the same result as we are doing the same thing without the thread class, but using the runnable interface, right? Quite cool. Now we have some concurrency problems. So because threads run at the same time as other parts of your program, there is no way to know in which order the code will run. So you never know in which order the code will run, right? So when the threads and the main program are reading and writing the same variables, so when they are reading and writing the same variables, the values are unpredictable. So they are completely unpredictable. The problems that result from this are called concurrency problems, right? Like you have a variable whose value is 0, then you increment it by 1, and you like you have started the thread, you increment that value by 1 outside the thread, right? And then you print out its variable's value, and in the thread also you are incrementing its values by 1, right? And after printing out that thing once, I'll just, the next example is based on that only. So we'll just see what is the concurrency problem in this. So we have extended from the thread class, we are using the thread class method. Okay, to see this concurrency problem, then we have a public static int amount equals 0. So we have a variable over here that's value is 0. Then in a main method we are creating a main classes object. Then we are starting our thread. We are printing out amount. So we are first of all printing out the value of amount, right? So then we are adding amount, and then we are what we are doing, we are printing it out again. But in a thread also we are adding the amount. So what will happen, first of all, this is lighter, so this will execute quickly. Then it will add amount, right? And then we don't know if it will add amount once again, or it will directly print this out and then add amount afterwards, right? Because threads are running in the background and you never know what is happening in the background, right? So over here you are printing out amount, that will be printed out 0, right? Because it is 0. Then you are adding the amount, so it is now 1. But then the thing to think about is that, will it print this first and then add the amount, or will it add the amount first and then print the result? So this will be always a different result, right? You'll get a different result. Like for example, you'll get sometimes 0 2, then you'll get 0 1 0 2 0 2. Anytime you can get anything, right? So this is the concurrency problem where you don't, where the result is unpredictable. So over here we got 0 1, because what happened basically, it started the thread, it printed out amount, so it printed out 0, then it added amount, and then it printed out, and then it added once again. Now if I run it once again, ah, again we are getting 0 1. Then I print it out once again. Oh, this replit is so slow. Again we are getting 0 1. So at some point of time we will also get 0 2. You're getting 0 1. So yeah, over here it depends, right? It is unpredictable. It can anytime come for a long time, 0 1 0 1 0 1, but 0 2 will also come, because I have tried it and 0 2 also comes and 0 1 also comes, right? 0 1. Okay, so this is basically unpredictable. Over here 0 1 is coming again and again. It depends on the situation, nothing is in my hand. Over here, it's just luck that 0 1 is coming like again and again like this. Sometimes it will come 0 2, sometimes it will come 0 1, right? So it depends, but over here we are getting 0 1 again and again. So to solve the concurrency problems, there's a isAlive method of our thread. So always avoid to change variables using threads. So you should always avoid to change variables that are there in main program using the thread, right? And then we have a isAlive method that is basically used to solve concurrency problems. So we have a main class that extends from thread. We have our amount variable. Then in a main method we are creating an object of a main class. Then we are starting a thread, right? And then what we are doing, while thread dot is alive, basically is alive will return you true or false based on whether the thread is still alive or not alive. It is alive or not alive means that whether the thread is still working on it, or working on your, basically working on your complex operation, or it is completed. So is alive will return false if the thread is completed already, and it will return true if it is working on your complex or anything that you're given in the thread. Anything that you're given in it, if it is working on it, it will give you true, right? So we are checking that while thread is alive, so while the thread is running, we will print out waiting, and once the thread has performed its complex calculation or anything, like over here we are just adding the amount, so then once it is done, we are printing out main equals amount. So because thread is basically adding an our amount variable, and basically we are waiting for a for a program to move on till the thread is not finished, right? So we are waiting till a thread is not finished. So when our thread is finished, amount variable's value will be incremented, so it will become 1, and then when we print its value we'll get 1. Then we increment it again, so it will become 2, and then we print it out again, so it will show you 2. So over here you will have no doubt, there's no unpredictability, you will always get 1 and 2. You'll always get 1 and 2. So you saw we are getting waiting so many times. Why we are getting waiting so many times? Because the thread is alive till that time, right? So the thread is alive. Waiting is showing that your thread is alive till that time. It is alive, alive, alive. It is there. It is working on your code. Once it is done, it basically, once it is done, that means that it has incremented the value. Then we are printing it. So once it is completed, it is showing waiting so many times. I've told you because it is still working on your thread, and once it is done, amount's value is incremented, and then we print it. So we'll get 1 because it is incremented once, so its value is 1, and then we increment it once again by 1, and if we just print it out again, we'll get 2. Right, so this was about threads, guys. I hope you liked the video. If you did, don't forget to smash the like button and share this video with as many people as you can. Thank you, guys. Bye. Stay safe, stay healthy, and keep watching my videos. Damn.